dear students, welcome to another video from V Chemistry Hub. My name is Venu Madhavi. Thank you for clicking on this video. In this video, I will talk about thin layer chromatography, applications, advantages and disadvantages of TLC. So please do watch the video completely for clear understanding. TLC is the basic type of chromatography and a little bit advanced version of paper chromatography. TLC works in the similar manner as that of paper chromatography. So, for understanding TLC, we need to know the basics of chromatography. So, chromatography are the techniques which help us to separate mixture of components to individual based on their mobility. So, this is the mixture of components present in the sample. So by using chromatography technique, we can separate them into a single component. So in this mixture of components, there are n number of components present in this. So by using chromatographic technique, we can separate them into a single component. So in any type of chromatography, we have two things in common. Those are stationary phase and mobile phase. So stationary phase means which is fixed and mobile phase means which moves or runs. So mobile phase carries all the sample. Due to the differential rate of all those substances in sample, few of them migrate further and few of them migrate less. So that's how we separate the components from a mixture. So for example, if we consider silica as a stationary phase, silica is a polar substance. So then we have to take a mobile phase, a non-polar one. If the stationary phase is in polar nature, then we have to take a mobile phase in non-polar nature. So this is the basic information of chromatography. Now coming to thin layer chromatography. It is based on the principle of adsorption chromatography. So or partition chromatography or the combination of both adsorption and partition. So it depends on the adsorbent, its treatments and the nature of solvent. The difference between paper and TLC. So as said, TLC and paper are quite similar, but there is a difference between paper and TLC. So paper chromatography requires a less preparation, whereas TLC requires more preparation time. The stationary phase of paper chromatography is water that is present on the paper cellulose. It is trapped in the cellulose filter paper, whereas TLC makes the use of glass plate which is coated with silica gel as a stationary phase. The main principle behind the particle separation in paper chromatography is partition type, whereas in thin layer chromatography is adsorption type. If we next one is TLC is a separation technique required very little sample. It is primarily used to determine the purity of a compound. A pure solid will show only one spot on developed TLC plate. In addition, tentative identification of unknown compound can be made through TLC analysis. So, TLC is widely used method for qualitative analysis to determine the number of components present in a mixture. Now coming to the main components in TLC, there are three main components in TLC. TLC plate acts as a stationary phase and solvent solution, that is mobile phase, and a sample. Now coming to TLC plate, so it is of two types, organic adsorbents and inorganic adsorbents. Organic adsorbent means cellulose and its acetylates, and charcoal and activated carbons acts as a organic adsorbents. Inorganic adsorbents means silica gel, alumina, magnesium silicate, calcium silicate. These are the inorganic adsorbents. So this is a TLC plate. All these acts as a stationary phase. Now coming to solvent solution, the inorganic mixture of lower polarity is used. That means low polarity is taken and high polar solvents are avoided to minimize the adsorption of any components of the solvent mixture. So now coming to sample, the preparation of sample involves the dissolution of sample in a suitable solvent used in making a mobile phase. And the solvent should be inert with the sample under analysis. So these are the three main components in TLC: TLC plate, solvent solution and sample. Now coming to the procedure of thin layer chromatography analysis, there are 5 steps included in this, and the first one is preparation of TLC chamber or the developing container. The second step involves the preparation of TLC plate, and the third step is spot of TLC plate. Fourth one is development of the plate, and the fifth one is visualization of the spot. Now coming to the procedure in TLC. So the stationary phase is applied on the plate uniformly and then allowed to dry and stabilize. Nowadays ready-made plates are also more commonly used. So with a pencil, a thin mark is made at the bottom of the plate to apply the sample spots as in paper chromatography. Sample solutions are applied on the line. Then mobile phase is poured in the TLC chamber to the level few centimeters. Now the plate prepared with the sample spotting is placed in the TLC chamber so that the sides of the plate with the sample line is facing the mobile phase. Then the chamber is closed with a lid. So sufficient time is given for the development of spots. Then the plates are removed and allowed to dry. So this is the block diagram. So this is the sample which is placed on the TLC plate and immersed in the mobile phase and covered with a lid. So after 5 minutes the spots will develop, and after 10 minutes the clear visualization takes place of the spots. So the sample spots are seen through a visualizing technique. Some of the visualizing techniques are UV light, iodine staining, KMNO4 stain, ninhydrin reagent. So ninhydrin reagent is used to detect amino acids and proteins. So after developing the chromatogram, we need to see the developed spots. Further, we need a visualizing technique. After visualizing the chromatogram, we need to find the retention factor of the developed spots. That is, the retention factor is also known as RF. We have to find the RF value. So this is the developed chromatogram. So the RF formula is distance traveled by the component by the distance traveled by the solvent. So this is the solvent front. So this is the starting point. So the distance between the starting point and solvent front is taken as A, and for example consider this point. So the distance from here to here is considered as B. So the retention factor of this particular component is B by A. That is the distance traveled by the component and the distance traveled by the solvent. So retention factor is a unique value for each compound under same conditions. And the RF values are in between 0 to 1. If a high RF value refers to a substance that is very non-polar and it travels more. If low RF value refers to a substance that is very polar and it travels less. For example, consider this component after development. So the distance is very less. So it is, as said, the low RF value refers to the substance that is very polar and it travels less. So this component travels very less. So this is all about the retention factor RF value. Now coming to the applications of thin layer chromatography. So it is used in monitoring the progress of reactions and identification of the compounds present in a given mixture, and it is used to determine the purity of a substance and analyzing the dye composition of fibers in forensic laboratory. and the detection of pesticides and insecticides in food and water, and for the identification of medicinal plants and their constituents, and for the analyzing ceramides and fatty acids, and assessing the radiochemical purity of radiopharmaceuticals. Now coming to the advantages of thin layer chromatography, it is a simple process with short development time, and it helps with the visualization of separated compound spots easily, and it helps in isolating of most of the compounds, and the separation process is faster and the selectivity for the compounds is high. The purity standards of the given sample can be assessed easily by using the TLC method, and it is a cheaper chromatographic technique compared to all the techniques. So here are the some of the limitations of thin layer chromatography. So they are, it cannot tell the difference between enantiomers and some isomers. And in order to identify specific compounds, the RF value for the compounds of interest must be known beforehand. And the TLC plate do not have long stationary phase. Therefore, the length of separation is limited compared to other chromatographic techniques. So, these are the limitations of TLC and advantages of TLC. Hope this video is helpful for you. If you are having any doubts, please do comment. Thank you. Thanks for watching.